So this is my solution to one of the problems listed on the PowerPoint, problem 4.10, which asks us to consider the uniform horizontal cantilever beam that is shown right here. It's fixed at point A, makes an angle with the force of 63 degrees. Applied at point B, the magnitude of the force P is 80 newtons. Point C is the center of gravity. The beam weighs 40 newtons and has a length of 2 meters. It asks us to determine the reactions generated at the fixed end of the beam. So looking at the problem here, I have our known is that it's fixed at A, makes an angle of 63 degrees at B, has a magnitude of 80 newtons. Point C is the center of gravity. The beam weighs 40 newtons and the length is 2 meters. Asks us to determine the reactions generated at fixed end of beam A. So here's my free body diagram. I have the reaction force split into X and Y. I have A, B, and C labeled where the weight W applies, and then the initial force P split into X and Y. So for the forces in the X direction, they sum to 0. So we have reaction at A, X, minus the reaction or the force of P times cosine of beta to get the X value is equal to 0. So RAX is equal to 80 times cosine of 63. So RAX is equal to 36.3 newtons. Doing the same thing for the Y direction, we have the reaction force at Y, or in the Y direction. We have the weight subtracted from that, and then the Y component of the force P also subtracted from that. So we get RAY is equal to 40, which is the weight, plus 80 sine 63 to get that P force in the Y direction. We get that RAY is equal to 111.3 newtons. And then the last part is to find the moment about point A. So the sum of the moment is 0. We have the moment at A minus 2 times P sine B, which is going to be our Y value giving that moment force at B. And it's multiplied by 2 for the length of the beam. And then we have minus the weight times 1 meter because it's 1 meter, 1 meter from the moment at A to the weight at point C. So we get that the moment at A is equal to 2 times 80 sine 63 plus 40. And so adding that all together, we get that the moment at A is equal to 182.6 Newton meters in the counterclockwise direction.